This is SpaceTime Series 29, Episode 28, for broadcast on the 6th of March 2026. Coming up on SpaceTime, mapping the mysterious upper atmosphere of Uranus, ESA's Planetary Defense Fly-Eye Telescope, and NASA's scathing report on Starliner. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has mapped the upper atmosphere of the distant world of Uranus for the first time. The new three-dimensional map, reported in the journal Geophysical Research Letters, reveals how the ice giant's unusual magnetic field shapes spectacular auroral activity above the planet's cloud tops. Astronomers observed Uranus for nearly a full rotation, detecting the faint glow from molecules up to 5,000 kilometres above the clouds. The new work provides the most detailed picture yet of where the planet's auroral activity forms and how energy moves through its atmosphere. It also confirms that Uranus's upper atmosphere has continued to cool over the past 30 years. Auroras occur when energetic particles become trapped in a planet's magnetic field and strike the upper atmosphere, releasing energy that creates a signature glow. Using NASA's Webb Space Telescope's infrared spectrograph, the authors mapped out temperature and density of ions in Uranus's ionosphere, a region where the atmosphere becomes ionized and interacts strongly with the planet's magnetic field. The measurements revealed that temperatures peak between 3,000 and 4,000 kilometres above the cloud tops, while ion densities reach their maximum around 1,000 kilometres up. The study's lead author, Paolo Taranti from Northumbria University, says it's the first time scientists have been able to see Uranus's upper atmosphere in 3 dimensions and trace how energy moves upwards through the planet's atmosphere, and even see the influence of its lopsided magnetic field. You see, Uranus's magnetosphere is one of the strangest in the solar system. Unlike Earth, where the planet's magnetic field is relatively aligned with the planet's rotational axis, Uranus's magnetic field is tilted by nearly 60 degrees and offset from the planet's centre. Mind you, the planet also rotates on its side. And all this means auroras sweep across the surface of Uranus in really complex ways. The Webb observations detected 2 bright auroral bands near Uranus's magnetic poles, together with a distinct depletion of emission and ion density between them, a feature likened to how magnetic field lines guide particles through the atmosphere. Similar darker regions have been seen at Jupiter, where magnetic field geometry controls particle flow. The Webb data also confirmed that Uranus's upper atmosphere is still cooling, extending a trend that began back in the early 1990s. The team measured an average temperature of around 426 kelvins, about 150 degrees Celsius, lower than values recorded by ground-based telescopes or previous spacecraft observations. This is SpaceTime. Still to come, the European Space Agency's Fly-Eye Planetary Defense Telescopes and NASA's scathing report on Boeing's Starliner spacecraft. All that and more still to come on SpaceTime. The European Space Agency's Fly-Eye Planetary Defense Telescopes are hunting for space rocks heading towards Earth. Asteroids, comets and meteors pose a constant threat to our planet. And it's not a case of if another space rock hits the Earth, it's a case of when. So, current inhabitants of this planet need to learn how to keep themselves safe from the next big one. The Chicxulub asteroid impact is probably the most famous space rock to hit this planet. The 10-kilometre-wide asteroid crashed into the Earth in what is now Mexico's Yucatan Peninsula some 66 million years ago, causing a mass extinction event that killed over 75% of all life on Earth, famously including all the non-avian dinosaurs. While extinction event impacts are rare, small and medium-sized space rocks are far more common, and they can still do a lot of serious damage when they hit the Earth. Now, while some of these asteroids hit the ground, others disintegrate in the Earth's atmosphere in what's called an airburst, like the one which caused the Chelyabinsk event in Russia back in 2013. They can create explosive events, resulting in shock waves that shatter glass and splinter wood, damaging or destroying buildings, and injuring anyone who happens to be in the way of the debris. The term near-Earth object, or NEO, refers to any natural celestial body, like an asteroid, a comet or a meteor, whose orbit brings it close to that of planet Earth. So far, more than 36,000 near-Earth objects have been identified, and 1,700 of them are on the European Space Agency's risk list, meaning they merit much closer follow-up observations. And that's where the European Space Agency's Planetary Defence Office comes in. It's designed to understand the current and future position of near-Earth objects relative to our planet. It'll then estimate the likelihood of an Earth impact, assess the consequences of any possible impact, inform relevant parties such as governments and national emergency response agencies, and develop methods to try and deflect hazardous asteroids, comets and meteors away from the Earth. To help achieve these goals, ESA is developing a network of fly-eye telescopes designed to scan the skies for rogue asteroids, comets and meteors, automatically flagging any that pose an impact risk. Fly-eye was inspired by the compound eye structure of an insect. It uses a single mirror inside the telescope, collecting light from a full-field view of the sky. And it then feeds those photons to a pyramid-shaped beam splitter with 16 facets, which then divides it all into 16 separate tubes. The secondary lenses inside these tubes focus the light on individual cameras, subdividing a region of the sky into 16 smaller images to grant a higher level of image quality over the telescope's large field of view. By placing fly-eye telescopes in both the northern and southern hemispheres, the entire sky can be scanned every 48 hours. So far, two 56cm testbed telescopes are primarily used to test data processing currently being developed for the Fly-Eye Telescope Array. One of the telescopes is located in Madrid, another at the La Silla Observatory in Chile at the European Space Agency's partner organisation, the European Southern Observatory. This report on Fly-Eye from ESA TV.
Hi, I'm Kelsey Brennan-Wessels for ESA Web TV. We join you from Milan, Italy at OHB Italia, where a new high-tech telescope to detect asteroids is being built. Traditional telescopes have a narrow field of view, which makes hunting for threatening asteroids a slow and tedious process. But the Fly-Eye has 16 individual cameras, mimicking the structure of a fly's compound eye, to offer an extra-wide field of view of 44 square degrees. With this field of view, the telescope will be able to detect asteroids at risk of hitting Earth in as little as a week in advance. An additional 3 telescopes are foreseen to be produced and placed in complementary locations around the globe to increase coverage and improve the efficiency of the network. Once this first Fly-Eye telescope is completed, it is destined for Mount Mufara on the Italian island of Sicily.
The telescope has to be mounted, has to be associated to an equatorial mount. The equatorial mount is a particular mount that allows to avoid that during the exposure time the stars track, and the stars in this way remain fixed in their position when we take a picture from the telescope.
And while the telescope is taking its pictures, it's important that the structure is very stiff in order to reduce vibrations that could blur the image and thus reduce the capability to detect very faint objects in the night sky.
And in that report on Fly-Eye from ESA TV, we heard from Fly-Eye Senior Optical Engineer Marco Chiarini from OBH Italia. This is SpaceTime. Still to come, NASA's scathing report on Boeing's Starliner spacecraft, and later in the science report, it seems warmer weather is causing humpback whales to swim closer to shore, in the process becoming more likely to be entangled in fishing equipment. All that and more still to come on SpaceTime. NASA has finally released its report into the many failures of Boeing's CST-100 Starliner spacecraft, and its findings are scathing. The investigation blamed what it called engineering vulnerabilities in Starliner, along with internal agency mistakes, which resulted in a botched mission that left 2 astronauts stranded in space. The The report found that Starliner is less reliable for crew survival than other manned spacecraft, and that NASA should not fly another crew on Starliner until all the technical issues are fully understood and corrected, and importantly, its problematic propulsion system is fixed. Following the premature mothballing of its highly successful space shuttle fleet after STS-135 back in 2011, NASA awarded contracts to Boeing and SpaceX under its Commercial Crew Program for 2 independent spacecraft systems to transport astronauts to and from the International Space Station. SpaceX developed their Dragon spacecraft, while Boeing offered the Starliner. NASA also established similar programs for the delivery of cargo to the orbiting outpost under a separate resupply contract, with SpaceX and Orbital Sciences, later Northrop Grumman, winning those contracts with their Dragon and Cygnus cargo ships. So far, Dragon cargo has undertaken 36 missions to the space station, while Cygnus has carried out 23. And the crew version of SpaceX's Dragon has proven to be just as successful, with some 23 manned missions now under its belt. But the record for Boeing's Starliner is far less attractive. In fact, it's downright appalling. There have been just 2 unmanned test flights, the first of which almost ended in disaster. And the 1 manned test flight that's so far been undertaken had to be abandoned halfway through, marooning the crew on the International Space Station for 7 months. The NASA report says Starliner faced challenges both during its unmanned and more recently manned missions. NASA Administrator Jared Isaacman says the technical difficulties encountered during docking with the International Space Station were very apparent. He says Starliner has lots of design and engineering deficiencies that need to be corrected. But for him, the most troubling feature revealed by the investigation wasn't the hardware, but the decision-making and leadership at NASA and Boeing. Isaacman says beyond technical issues, it's clear that NASA permitted overarching program objectives to influence engineering and operational decisions. The ensuing investigation identified an interplay of combined hardware failures, qualification gaps, leadership missteps, and cultural breakdowns that created risk conditions inconsistent with NASA's human flight safety standards. Starliner was launched on June 5, 2024 on its first manned test flight to the International Space Station. Originally planned to be a 14-day mission, the flight was eventually forced out to 93 days after propulsion system failures hit the spacecraft in orbit. Because of the loss of spacecraft maneuverability as they approached the International Space Station, NASA has now classified that test flight as a Type A mishap. That's the same classification as the deadly Challenger and Columbia space shuttle disasters. While there were no injuries and the crew eventually regained control prior to docking, the decision to give it the highest level classification designation recognises that there was a potential for a significant, possibly fatal mishap. After reviewing the flight data and then conducting ground tests at the White Sands Missile Range in New Mexico, NASA decided to return the spacecraft to Earth empty, with no crew on board. Starliner did eventually land safely at White Sands in September 2024. But the stranded crew were forced to remain on station until March 2025, when a Dragon spacecraft was sent up by Boeing rival SpaceX to rescue them. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. The United States Department of War has selected Pratt & Whitney to power its new 6th-generation stealth jet fighter, the F-47. The XA-103 adaptive cycle engine was selected ahead of General Electric's XA-102 power plant. The 3-stream adaptive cycle design can direct air to the bypass third stream for increased fuel efficiency and cooling, or to the core and fan streams for additional thrust and performance. The engine thrust hasn't been disclosed, although it's expected to be somewhere in the 35,000 to 40,000 pounds of thrust class. The new F-47 fighter is expected to reach speeds in excess of Mach 2.2 and have a ceiling of 65,000 feet. All that's comparable with the current F-22 Raptor, currently considered the best air superiority fighter ever built. But the F-47 will also support more advanced systems, including AI integration, drone coordination, and potential future directed energy capabilities. Eventually, the F-47 will replace the F-22 Raptor. It's expected to undertake its first test flight in 2028, with operational entry currently targeted for the following year. The US Air Force plans to procure an initial 185 aircraft. A new study has found that warmer weather is causing humpback whales living off the west coast of the United States to become entangled in fishing equipment more frequently. The findings, reported in the journal PLOS Climate, show that higher sea surface temperatures are pushing whales closer to shore as they follow their food supplies. The authors found a 300% increase in fishing gear entanglements during warmer years. The study shows that during major marine heatwave events such as 2015 and 2016, record numbers of entanglements were recorded. And scientists have finally figured out what makes sneakers squeak. Using high-speed imaging, the authors found that when basketball shoes slide on a polished court, the resulting squeak is caused by deformations in the soft material rippling across the surface. The findings, reported in the journal Nature, used high-speed imaging to capture the rubber soles pulsing in bursts across the court, finding the pitch of the squeak matches the rate of the burst, which is determined by the stiffness and thickness of the shoe's sole. In additional experiments with other samples, the authors showed that if a soft surface is smooth, the pulses are irregular and produce no sharp sounds, whereas rigid surfaces, like the grip patterns on sports shoes, produce consistent pulse frequencies, resulting in high-pitched squeaks. And these findings aren't just belly-button fluff. They could also provide new insights into the effects of a range of friction situations, from synthetic materials to geological fault lines. It's been revealed that a lab at the University of California, Los Angeles was studying psychic abilities, ghosts and auras during the 1970s. The parapsychology lab conducted experiments on telepathy and other psychic abilities. But as the skeptic's Tim Mendham points out, the big problem was that the researchers were true believers rather than neutral scientists searching for the truth.
Okay, the story is that in UCLA, University of California, Los Angeles, in the 70s, this laboratory was started up by someone named Thelma Moss, who was initially an actress, and then she became a scriptwriter, and then she had a bit of a depressive period after her husband died, and she had some LSD psychotherapy to clear her depression that was supposed to be working. Eventually, so therefore, sort of once she came down for her depression, supposedly, she did a study in psychology at UCLA, did a PhD, she began teaching there in 1966, and the following year she opened what's called the Parapsychology Lab. It was not sanctioned by the university, it was providing of volunteers and private funds, but it was housed at the Neuropsychiatric Institute. It's one of those things the university says, oh yeah, so-and-so over there in the corner, they got some interesting ideas, they'll just let them run and go with it and don't interfere too much. So when she opened the laboratory and started studying people with psychic abilities, apparently the word spread like wildfire. But there's some problems with the word spreading like wildfire. Is that you get a lot of people who have a vested interest coming along. One of them was a fellow who was studying psychology at California State University, who also said he experienced psychic abilities. So he became an assistant, a research assistant, which is like saying, I've got someone who believes something trying to prove that the belief is true. That's a problem. There are other people who had psychic abilities, they claimed, and this one person I referred to who volunteered for the thing also went out and decided that someone he studied had been dealing with poltergeists and that sort of stuff. So you have to be careful of people with a prior belief acting as your neutral umpires in a scientific experiment. It eventually closed after a while and it sort of disappeared. But that's why it's a bit of an unknown psychology laboratory, as opposed to others. There was Stanford Research Institute, had a long-running one that was funded by the CIA. Two guys named Targ and Puthoff were there for a long, long time, and some of them are still commentators on the field. Harvard, that had maybe Duke University, who had a long-running laboratory to test psychic abilities way back to the 20s. He was one who used the Xena cards, the X and the Y, X and the square and the circle and that sort of stuff. So there have been more famous parapsychology labs. None of them have produced definitive evidence of psychic abilities.
That's not to say that these things weren't legitimate at the time, because the idea is to find out if they were, because we didn't know. So that's right.
And that's perfectly good to do that. It was something the skeptics would endorse, do some proper scientific evidence, but watch out for the way you're doing it. And in many cases, these things were particularly slack. I mean, employing someone who believes in this thing as your assistant, who's going to be testing people, means there's a bias in there, right? And that's not good. Allowing your subjects to wander freely when they're being tested, as happened with Uri Geller in the SRI test, is not good practice. And there are people who go there and look at it. Yes, do the testing, but do it properly, please. And when you look at the test situations, you find there's a lot of loopholes and holes in the theories and the practices, which ends up impacting negatively on the results that they supposedly have.
That's the skeptic's Tim Mendham, and this is SpaceTime. that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.